Assalamualaikum. So today we would like to present our group project assignment, which is the application of Solix Mechanics 2. Before we go further into the presentation let me introduce our group members. The first one is myself, Muhammad Nur Hazi Aiman bin Majni Hizam, with metric number DD200-101. The second members of the group is Muhammad Roshaidi bin Nurzan Zari, with metric number DD2089. The third member of the group is Abu Bakr Saleh Yaslam Balfakir, with metric number BD190002. The fourth member is Muhammad Shamsuri bin Mazlan, with metric number CD2034. And the last members of the group is Muhammad Ashraf bin Yusuf, with metric number DD2088.
Assalamualaikum warahmatullahi wabarakatuh, and my name is Muhammad Shamsuri bin Maslan. My neighbor cut metric is CD2034, and today I will intro about solid mechanics. Solid mechanics is concerned with a deformation and motion of solid material. It is one of engineering science component because of variety choice of material accessible. For example, we can conclude that steel, concrete, plastic, and biological material. Solid mechanics can be called as a rigid body. So there will be two types of rigid body in mechanics. The first one will be static. It's when material structure are in rest, or we can call as equilibrium. So the second one will be a dynamic. Dynamic is concerned with study of force and effect in motion. For example, we can study about the swing of the pendulum. And the next will be a material of mechanics, which focus on deformable materials and structure. There are another theory which is elasticity, which state that if material deforms while loaded, it will return to original once discharged the loaded. There are advanced theory. The first one will be plasticity theory, which used to model the behavior of material after they have been permanently deformed. The second one will be the theory of viscoplasticity, viscoelasticity, in which the models are well-defined material with several fluid-like properties. And the third one will be the combination of two, which is plasticity and viscoelasticity, that combined will be named as the viscoplasticity. It is beneficial in materials like mud and gas. So we go to the next slide. There will be 5 topics in solid mechanics that we get in the real world application. So the first one will be the deflection of beam, buckling of columns, strain energy, thick cylinder, and theories of elastic failure. So we start with the deflection of beams. Deflection of beam is a structure and machine design member or beam that can be overcome the force applied laterally or transversely to the edge. As we can see on the diagram, they show the deflection, how deflection can be from the edge. So deflection can be recalled as displacement. It can happen when external applied loads or weight of the structure has been changed. So in a simple beam, the compressive and tensile force above and below the neutral axis will result in lengthening and shortening, which like a compress and tension of longitudinal fibers above and below the neutral axis. Thus, it will cause a bending moment in the beam and the displacement of beam fibers from original position. And we go to the next slide. For example, we choose in a real-life application is a diving board, where the one end of the board is fixed and give the other end the bounce, which is required for the athlete to give a graceful swan dive. So the diving board can be referred to as a cantilever beam, where the loads or weight of a person being applied on the other end will cause the board to bend, or can be called on elastic curve. So as we can see on the diagram, it shows how the cantilever beam effect.
Next, the second application of the solid mechanics 2 is buckling of columns. Buckling of columns is a form of deformation or sudden change due to high axial compressive forces. The axial load is applied on the center of gravity of the structural cross-section along the direction of the neutral axis. Buckling occurs when the compressive forces applied into the column are exceeding the value of critical load, PCR. the column will not buckle if the force applied is not exceeding the critical load of the column. As you can see here, figure 2 shown a column that in the edge of buckling due to the compressive forces applied into the column. So for the application of the bucklings of columns, we choose a rectangle column at pedestrian walkway. In real-world application, column used to support the structural component and solid component. As the load is applied into the column, it is prone to experience certain deformation. The column will not buckle if the force applied is not exceeding the critical load of the column.
My name is Abu Bakr Salah Islam Belfagia. My matric number is BD 190002. Strain energy. Strain energy is internal energy stored or absorbed in a body due to the deformation. There are two types of strain energy, which are elastic energy and plastic energy. Elastic energy is an elastic range, which is when the force is unapplied, the material is recoverable. A real application or real-world applications, tightening bolts and nuts are related to strain energy in torsion, while the nut is the paired female element with internal threads that match the bolts. Bolts is a type of fastener usually made from metal besides. Bolts are used to hold the materials or objects together. The bolts are designed to withstand stress, known as a material yard strength. Stud bolt, a threaded fastener without a head and used with two nuts on either side to assemble. There are two types of bolts that are commonly used for this type for fastener machine and stud. Stud bolts are most commonly used in the flange connections. Torsion is the twisting of a bolt. As it is tightened, torsion produces shearing stress that is vertical to the radius in the circular cross-section of the bolt. The twisting is a method of creating torsion in the bolt by stretching it and causing it deform. And thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rushadi bin Zazari. My matrix number is DD20089. Today I would like to explain about the thick cylinder, which is for the real world application. Thick cylinder is the method to solve the problem, which is the cylinder wall thickness would be greater than 1/20 times of its internal diameters. For the real life application for the thick cylinder is the pressure vessel. Pressure vessel usually to be designed for the liquid or gas that have their pressure, which is from the reaction. So usually pressure vessel to be designed to the cylinder shape or sphere shape. For the common characteristic for the pressure vessel that have radial stress and tangential stress, which is the hood stress, there must be concern to design the pressure vessel.
Assalamualaikum warahmatullahi wabarakatuh. Firstly, my name is Muhammad Ashraf bin Muhammad Yusof with matric numbers DD200088, and now I will be presenting the theories of elastic failure. While dealing with design of structures or machine elements or any component of a particular machine, the physical properties or chief characteristics of the constituent materials are usually found in the result of laboratory experiment, in which the components are subjected to a simple stress condition. The most usual test is a simple tensile test in which the value of stress at yield or fracture is easily determined. However, a machine part is generally subjected simultaneously to several different types of stress whose actions are combined. Therefore, it is necessary to have some basis for determining the allowable working stress so that failure may not occur. Thus, the function of the theories of elastic failure is to predict from the behavior of materials in a simple tensile test when elastic failure will occur under any condition of applied stress.
Next, we move to the method of assessment for these projects. So, for the method assessment of this project, we choose a topic, a bucklings of columns. So, we choose a column, a single structural column that originally we assume that is fixed both ends and there is an aluminium I-beam inside of the column. So, we will use the safety factor to determine the largest allowable force that could be applied into the column. In order to determine the largest allowable forces that can be applied into the column, some assumptions are made into the column. When the column is subjected to load and experience deformation or bending. So the assumptions are made as follows. There are 10 assumptions. The first one, initially the column is perfectly straight. The second one, the column is subjected to axial corrosive forces. The third one, the axial forces is passed through the centroid of the column. The fourth, the column will buckle about the principal axis of the cross section that has the least moment of inertia. The fifth one, the cross section of the column is symmetrical in the x and y axis. Next, the column is fixed and support for both sides. The value of critical stress is lower than the yield strength of the material. The eighth one, the failure of the column only occurs due to buckling. The second last one, the length of the column is larger than its cross-sectional dimensions. And the last one is the stress in the column is within its elastic limit. Next, we move to 3.1, the least moment of inertia. Least moment of inertia is the principal axis of the cross-section of the column that has the lowest resistance to buckling. In other words, it is the weakest axis which tends to deflect or deform first. So, as you can see here, we can use equation 1 to determine the value of moment of inertia, where Iyy is the area moment of inertia, and I is the moment of inertia of the body, and A is the cross-sectional area of the body, and H distance between the axis and the reference axis of the body. The value of I depends on the shape of the column. So for this project, the value of area moment of inertia on the y-axis is chosen because the y-axis has the lowest resistance to buckling due to the value. As you can see here, the value of area moment of inertia on the y-axis is smaller than the value of area moment of inertia on the x-axis, which means on the y-axis it tends to deform first or buckling than the x-axis. Next, we move to 3.2, cross-section of the column. The cross-section of the I-beam is obtained from the link as shown. We move to 3.3, which is the length effective. length effective, the value of K depends on the end of support types used by the column. So for this project, the end of support on both sides of the column is fixed ends. So we can use the equation 2 to determine the value of length effective of the column, where LE is the length effective of the column, K is the moment of inertia of the body, and L is the actual length of the column. We move to 3.4, which is the calculation. So first, the value of length effective of the column is found by using equation 2. So for this project, the column is fixed ends and the value of K is 0.5 will be multiplied with 4, which is L is the actual length of the column. So the value of L effective of the column is 2 meter. Next, the critical load is found by using the formula below. E is the Young modulus of the material of the column. So for this project, we use aluminium. And I is the least moment of inertia. So we substitute the value into the formula. So for the Young modulus, which is E, is 68.9 exponents power of 9, will be multiplied with pi power of 2 and multiply with the value of least moment of inertia, which is the y-axis. The value is 1.19 exponent power of -6 and will be divided by length effective, which is the value of length effective is 2 and with power of 2. So for the value of the critical load for this project is 202.3 kN. Then we use the value of the critical load to find the value of the critical stress. So the value of the critical stress can be obtained by dividing the value of the critical load with the area of the column. So for this the value of the critical stress for this project is 72.25 megapascal. Since the value of the critical stress is lower than the stress of the material, thus the application of the Euler equation is appropriate. As you can see here, 72.25 megapascal is lower than the value of sigma y, which is the stress of the material, 276 megapascal. Lastly, the value of the P lovable can be obtained as shown below. The value of the P lovable can be determined by dividing the value of the critical load with the value factor of safety. For this project, the value of the factor of safety is 3. So after dividing the values, we obtain that the value of the P lovable is 67.43 kN. The P lovable obtained is a force that 3 times safe with respect to safety of factor that could be applied into the column.
Okay, now we continue to the result and discussion of the topic. Firstly, we begin by determining the effective length. Then we use the value to compute the critical load when the Young modulus is determined based on the type of material used, which is 68.9 GPa, and the summing yields of critical load of 202.3 kN. Then we use the equation of PCR over A. From there we can determine the critical stress, which comes out as 72.25 megapascal. In this case, the Euler equation is appropriate because the value produced is less than the material yield stress, which is 276 megapascal. When the safety factor is multiplied by 3 times, the ultimate value for P is permitted to the structure is 67.43 kN. When only exerting axial compression until the tension in the column approaches the material yield stress, it might cause the column to fail. However, the critical buckling stress is smaller than the material yield stress. The column will buckle and fail before the yield stress is reached. Based on this research and the calculation made, The column has a low probability of failure since the stress calculated is well below the limit of the material itself.
I continue from the part discussion, result and discussion. So, the column has fixed end supports. On the field study, we have 4 types of the end supports, which is the first is pin end support, the second is fixed and free end support, the third is fixed end support, and the fourth is pin and fixed end support. The support affected the value of the buckling load or the critical load, which is to define the critical load that's influenced by the effective length. The effective length obtained from the actual loads times K. K represent to the end supports. So, for this discussion, that's occur the fixed end support. So, the K value is 0.5 from the actual. So, the effective length for the fixed end support for this discussion must half from the actual length. Next, the column could not have slenderiness because the critical stress for this discussion that's unequal to the yield stress. Next, the impact of the safety factor to be made sure that the column has allowable stress, which is the safety factor as a precaution from the column to buckling, and safety factor also puts the limits of the load to the column from failure or buckle. Analysis can express the how much stronger the column. From the calculation, that shown the column is strong enough and do not occur the buckle. The comparison between manual calculation and Excel spreadsheet calculation. So for the both result, that proven the right calculation, but have a big difference when run off the value and have a plus minus, and that's the calculation still relevant as long as we use the same equation to define the critical load, critical stress, or allowable stress. As for conclusion, the theory of application of solid material is based on the deflection of beam, buckling column, strain energy, thick cylinder, and the theories of elastic failure. So from the result, we are able to complete our objective of this project, as the value of effective length, safety factor, and critical load are crucial to prevent the column from buckling. The manual calculation and Excel spreadsheet are proved to have exact value of critical load, which is 202.3 kN and 202.36 kN, which have a plus minus 0.002 kN. The safety factor are used, which we want to ensure the column have the amount of allowable force required to withstand the buckling. So from the result conclusion, we get the same amount for the allowable force is 67.43 kN in manual calculation and Excel spreadsheet. So by comprehending the material design, we may advocate solid mechanics in real world application, as it benefits humans in variety ways. Thank you.